Welcome to Chapter 2 of the RAG Introduction series. In this chapter, we'll explore how to transform text into searchable vectors and store them efficiently. You'll learn about embedding concepts, similarity metrics, and three major vector databases: FAISS, ChromaDB, and Pinecone. Understanding embeddings is crucial because they're the foundation of semantic search that powers RAG systems. Embeddings are numerical representations of text in a high-dimensional vector space. The key insight is that semantically similar texts end up close together in this space. For example, machine learning and artificial intelligence would have similar vector representations, while machine learning and cooking recipes would be far apart. Modern embedding models produce vectors with hundreds to thousands of dimensions, typically 1536 for OpenAI's models. These vectors capture the semantic meaning of text, enabling computers to understand similarity in a mathematical way. Cosine similarity is the most common metric for comparing embeddings. It measures the cosine of the angle between two vectors, ranging from -1 for opposite directions to 1 for identical directions. The formula divides the dot product of two vectors by the product of their magnitudes. In practice, high similarity scores like 0.85 indicate related concepts, while low scores like 0.25 suggest unrelated content. Most vector databases use cosine similarity internally, though some also support Euclidean distance or dot product as alternatives. Several embedding models are available, each with different trade-offs. OpenAI's text embedding 3 small produces 1536-dimensional vectors with good quality and reasonable API costs. The large variant produces 3072 dimensions with the highest quality but slower and more expensive. For local deployment, Sentence Transformers offers free, open-source models. The multilingual model works across languages with 384 dimensions, while Distilu Space Multilingual Case v1 produces 512-dimensional vectors and is a common choice for Japanese and other non-English text. For production RAG systems, I recommend OpenAI's large model for quality-critical applications and the small model or local alternatives for cost-sensitive deployments. FAISS, developed by Facebook AI Research, is a library for efficient similarity search. It runs locally without requiring external services. FAISS offers multiple index types. Index flat L2 performs exact brute force search, ideal for small datasets. Index IVF flat uses clustering for approximate search, enabling faster queries on large datasets at the cost of some accuracy. Key features include high-speed search optimized for CPU and GPU, the ability to save and load indices for persistence, and integration with LangChain. FAISS is excellent for prototypes and offline applications where you don't want external dependencies. ChromaDB is an open-source vector database designed for AI applications. It excels at metadata filtering, allowing you to search within specific categories, date ranges, or custom attributes. A powerful feature is MMR search, maximal marginal relevance, which balances relevance with diversity. By adjusting the lambda parameter, you can get results that are both relevant to your query and diverse in content, avoiding redundant similar results. ChromaDB supports both in-memory and persistent storage, making it suitable for development through medium-scale production. The API is straightforward and integrates well with LangChain. Pinecone is a fully managed cloud vector database designed for production scale. Unlike FAISS and Chroma, you don't manage infrastructure. Pinecone handles scaling, replication, and availability automatically. Key features include namespaces for organizing data, hybrid search combining vectors with keyword filters, and high availability across regions. Pinecone is a usage-based paid managed service, priced around the scale of the workload you run on it. It's the recommended choice when you need to scale to millions of vectors, require high availability, or prefer a managed service over self-hosting. Let's compare the 3 vector databases to help you choose. FAISS is a local library best for small to medium datasets and offline environments. It's free but requires self-hosting and has limited metadata capabilities. ChromaDB offers more flexibility, running locally or as a server with powerful metadata filtering. It's great for development and medium-scale applications. Pinecone is a cloud service with the highest scalability and full management, but comes with API costs. Choose FAISS for prototypes and offline use, ChromaDB for development and metadata-heavy applications, and Pinecone for production systems requiring scale and reliability. Let me walk you through implementing similarity search. Step 1. Prepare your documents with content and metadata. Step 2. Generate embeddings for each document using your chosen model. Step 3. Index these embeddings in your vector database. Step 4. When a query comes in, embed it using the same model and search for similar vectors. Step 5. Return the top K most similar documents with their similarity scores. The complete pipeline can be implemented in just a few lines of code with LangChain, which handles the integration between embedding models and vector stores. Let's recap Chapter 2's key points. First, embeddings transform text into semantic vector space where similar meanings cluster together. Second, cosine similarity measures relatedness on a scale from -1 to 1. Third, you have three main vector database options: FAISS for local and offline use, ChromaDB for flexible development with metadata support, and Pinecone for managed cloud production. Fourth, choose based on your scale requirements, needed features, and deployment preferences. In Chapter 3, we'll explore advanced RAG techniques including query optimization, re-ranking, and hybrid search to significantly improve your RAG system's accuracy.